Hello and welcome to the Geomestic channel. Today we're going to dig into one of the building blocks of trigonometry known as the tangent ratio. If you go down to the description, you'll find a link to a guide notes worksheet that will help you follow along with this video. You can press pause, go print that off, and I will wait right here for you. Now, trigonometry. Trigonometry, if you break that down into its two roots, we've got trigon and metry. Trigon literally just means triangle, a geometric triangle. And metry is measure of. So trigonometry literally just means measuring triangles. What it is the study of the relationships of the sides and the angles in triangles. Now, the beginnings of trigonometry go back well over 2,000 years ago, with its roots primarily in Greek astronomy. But as with most mathematical concepts, these trigonometric relationships were developed in Arabic and Indian cultures, as well as others. Now, the main idea here is that the measures of angles in right triangles tell us things about the lengths of its sides. So we got a right triangle here. We'll go A, B, C. Okay, so the measures of the angles can lead to information about the lengths of its sides and vice versa. Now, what likely started with just crude measurements and estimations slowly blossomed over time into more precise calculations as mathematicians developed more concrete formulas. Now, eventually, this led to tables of values that could be referred back to for any specific angle measures. And then in the 17th century, the slide rule, this guy right here, was invented. And this thing can be used to find values for logarithms, exponentials, trigonometric functions, and then just basic multiplication and division. Then with the invention of the scientific calculator, this thing was kind of phased out as all these relationships were programmed into our modern day calculators and computers. Now, what values and relationships are we talking about? Before we get to the numbers, I want to back up a little bit here. Okay, so in a right triangle, you always have two acute angles and you have a right angle. And regardless of the size of the triangle, your two acute angles, A and B, will always be complementary to each other. Okay, complementary just means they have a sum of 90. Now, why is that? You got a triangle is 180 degrees. You've already got the right angle, which is 90 degrees. So between the two angles here, A and B, they have to have a sum of 90. They got to add up to 90 degrees. Okay, so for any given pair of complementary angles A and B, there's a whole family of similar right triangles that behave in the same way. Okay, namely, that the leg opposite of angle A over the leg adjacent to angle A must be constant. Okay, so this is what's known as the tangent ratio. So the tangent ratio, you can shorthand here. So the tangent ratio for angle A, so tangent of angle A, is equal to the leg opposite of angle A over the leg adjacent to angle A. So opposite of angle A means the leg that is on the other side of the triangle from angle A. It's not touching angle A. So the leg opposite of angle A, which would be this leg right here, the length of that leg, over the leg adjacent to angle A. Adjacent just means next to. So the leg of the triangle that is adjacent to angle A, that would be right here. Okay, so again, regardless of the size of the triangle, whatever this angle is, the ratio of the side opposite of that over the side adjacent to that leg is the same. So even if I had maybe an angle A, the same angle, just a triangle a little bit smaller, okay, obviously the sides of this triangle are going to be smaller than the sides of this one, but if they're similar, meaning they're just the same shape, just different sizes, that ratio of those two sides is going to be the same. Maybe this is 5 and 5 and this is 1 and 1. Okay, but they would reduce down to the same thing. Okay, so that's the tangent ratio, opposite leg over the adjacent leg. Now, if I put some numbers in here, let's just say this is a 3, 4, 5 right triangle. So a 3, 4, 5 right triangle. if I said I wanted to find the tangent ratio for angle A, what I'm going to do is I'm going to take the length of the leg opposite of angle A, which is 4. I'm going to put it over the leg adjacent to angle A, which is 3. So 4 over 3. That would be the tangent ratio for angle A. I can also take the tangent ratio for the other acute angle in this triangle, which is angle B. So I can say the tangent ratio for angle B. I do the same thing. What is the leg opposite of angle B? Opposite on the other side of that would be 3 over the leg adjacent to B, which is 4. Okay, so the tangent ratio for angle B would be 3 over 4. Now notice that these two ratios are just reciprocals of each other, which should make sense because the leg that is opposite of A is the same as the leg that is adjacent to B, so these are just going to be flip-flopped here. Now, why can't you take the tangent ratio for angle C? Well, there's a couple problems. First of all, if I look at angle C and I use the definition here, the leg opposite of angle C. Well, what side is opposite of angle C? It's the hypotenuse. It's not even one of the legs of this right triangle. So the first problem is I don't have a leg that is opposite of angle C. I have the hypotenuse that is opposite of angle C. And then the leg adjacent to angle C, what sides are next to angle C? They're both legs. I have two legs that are adjacent to angle C. So when we're talking about the tangent ratio, we're only talking about ratios in relation to the two acute angles. I can't take a tangent ratio for the right angle. Okay? Now I want you to think for a second, what kind of triangle would have an angle with a tangent ratio of 1? Or 1 over 1? So if I have a right triangle, and my tangent ratio, we'll just use A, my tangent ratio for angle A is 1 over 1. What would that mean? That would mean that my opposite leg and my adjacent leg would have to be the same, value. It could just be 1 and 1, but it could be any two numbers that are equal, any two numbers that are the same that would reduce down to 1 over 1. Okay, and what that would mean is that this is really an isosceles right triangle. Okay, I would have two sides that are the same. These two would be equal. Okay, and you might recognize this as one of our special right triangles. This is the 45, 45, 90 right triangle. An isosceles right triangle is a 45, 45, 90. Now, I'm going to grab the calculator here. Hopefully this is easy to see. Okay, so tangent ratios are all programmed into any scientific calculator. I've got my old trusty TI-83 Plus right here, so this is a graphing calculator. But any scientific calculator will have these tangent ratios programmed in. Now, since we know that the tangent ratio for a 45-degree angle would have to be 1 over 1, because the opposite leg over the adjacent leg, those two numbers are going to be the same, I can use the calculator to kind of verify this and see how it works. So I've got my calculator on here. You can see I've got these three buttons. You can see sine, cosine, tangent are what these three buttons are. We're using the tangent button today. And every calculator is different. For the most part, most graphing calculators, you're kind of going to do this the same way. If I hit that tangent button, you can see tangent pops up right there, and then it opens up a set of parentheses. So if I type in my angle, in this case I'm going to take the tangent of a 45-degree angle, and I hit enter, you can see that it gives me a value of 1. Okay, so my tangent ratio for a 45-degree angle is just 1 over 1. Now some calculators, if you use scientific calculators, you'll have to type the angle first and then the tangent button. You kind of have to experiment. Make sure you're in degrees. Some calculators will be defaulted into a radian mode. So if you check your mode, make sure you're in degrees. But I know that a tangent ratio for a 45-degree angle is going to be 1. Now, if I have a tangent ratio, maybe a 46-degree angle, I can see that it's very close to 1. You can see there just a little bit more than 1.0355. And if I take a tangent ratio of a 44-degree angle, since it's very close to 45, I know it's going to be very close to 1, just a little bit less in this case. Okay, so you can play around with your calculator. You can see based on your angle, your tangent ratio is going to change. Okay, so what are the benefits of tangent ratios in your calculator? Let's get to the good stuff here. Okay, so we've got a right triangle, and let's say that we're measuring distances. We've got 10 on the ground, we've got a 62-degree angle, and we're looking for this missing side. Okay, so really where this shines is when we're looking for missing pieces in right triangles. Okay, maybe you're trying to find a height of something indirectly where you can measure a distance on the ground and you have a way to measure an angle looking up to the top of whatever you're trying to measure. Maybe you're looking for the distance across an area of land or a river or something like that where you can measure one side but you can't measure the other. Okay, so that's where this is really going to shine. So I've got a 62-degree angle here, 10, and a missing side. So what I'm going to do is I'm going to use this tangent ratio to set up a little proportion. I'm going to use some algebra to solve for this side. So this is real simple stuff because the calculator is really doing the bulk of the work here, knowing what those ratios are. Okay, so what I'm going to do is I'm going to start with my acute angle. In this case, I know one of them is 62 degrees. So what I'm going to do is I'm going to write the tangent ratio for a 62-degree angle. So the tangent of a 62-degree angle is equal to, now remember your tangent ratio is the leg opposite of your angle over the leg adjacent to your angle. So what is the leg that is opposite of 62 degrees? That's x. So in the top of my ratio, I've got x. And then what is the length of the leg adjacent to my angle? That's 10. Okay, so my tangent ratio is x over 10. Now I'm missing x, which is fine, because what I have is the makings of a proportion. A proportion, if you remember, is just a comparison of two equal fractions. I can put this tangent 62, because this is just a number, it's just a ratio. I can put that over 1 and not change the value, because now I have a proportion. And to solve proportions, you can what's called cross multiplication. So I've got x times 1, which is just x. I've got 10 times tangent 62, or tangent 62 times 10. So I've got x equals 10 times tangent of 62. And this is something that I can type right into the calculator to figure out what this value is going to be. So if I go over to my calculator here, I've got 10 times tangent of 62 degrees, which again is just a number. And we get a value which is about 18.81. So you are going to be doing some rounding here. Just check your instructions for what decimal place you're going to be rounding to. In this case, we've got 18 point. We'll just go 81. We'll go to the hundredths place. Okay, and maybe this is feet, maybe this is miles, maybe this is some other dimension. So check your labels as well. I'm going to go label-less here just for general purpose. So 18.81 would be the length. Now the best part about these types of problems is if they're drawn to scale, it makes it real easy to check the reasonableness of your answer. If this length is 10, I can tell that this length, this is the longer leg, I know my answer has to be more than 10, and it looks like it's pretty close to double that length, which would make sense for my answer here being 18.81. Okay, so it's really easy to kind of check your answer and make sure you're in the ballpark, because anytime you use technology using the calculator, you're always apt to hit a wrong button or put things out of order, so you can tell when you've done something wrong. Okay, let's do another. Okay, similar type of problem here. Okay, in my right triangle this time, I've got the height of that triangle, or the altitude of that triangle, is 6. Distance here across the bottom is missing. I've got a 22-degree angle here in the corner. Now we'll set it up the exact same way. Start with my acute angle. In this case, I've got a 22-degree angle. So I write the tangent ratio for a 22-degree angle, which again is the leg opposite of my angle. Opposite of the 22-degree angle is 6, over the leg adjacent to the 22-degree angle, which is x. Okay, don't forget that if your hypotenuse and your longer leg look similar in size and you don't know which side is the longest side, always go back to your right angle. Your hypotenuse is always opposite of your right angle. Okay, so we've got our tangent ratio for the 22-degree angle. Again, we have a proportion if we put this value over 1. And take the cross product 1 times 6, which is 6. I've got x times tangent 22. And I'm here. Okay, so notice the difference between this problem and the last one we just did is that in the first problem, my x value is on the top of my ratio. In this case, my missing value, my variable, is in the bottom, is in the denominator of that fraction, which is fine. I still cross multiply the same way, but this time to solve, I'm not multiplying, I'm dividing, because if I want to get x by itself, I'm multiplying by the tangent of 22 degrees. To get rid of that, I'm going to divide both sides by the tangent of 22 degrees. So if I divide by tan 22 over here, tan 22 over tangent 22 is 1, that's gone. I also divide this side by tangent of 22 degrees. So I've got x equals, I've got 6 divided by, or 6 over the tangent of 22 degrees. So go over to my calculator. I'm going to type in 6 divided by tan 22. I always close the parentheses just to make sure I'm not leaving anything hanging. Okay, and that gives us x equals 6 divided by tangent 22 is 14 point, we'll stick with the hundredths place, 14.85. And once again, if I go over here to my picture, obviously mine's not drawn to scale necessarily, but kind of get a good idea of whether we're in the ballpark, and you can see shorter leg being 6, I've got a longer leg, okay, a little bit more than double, that looks about right, so 14.85. Check your labels, make sure you get those on there if you need them. Okay, let's do one more. I'm going to switch it up just a little bit. Okay, so in the first two examples, in both cases, I had the angle, but I was missing one of the sides. You can also use this tangent ratio if you're missing an angle. So let's say we've got 7, 13, and maybe this angle, the acute angle, is what we're missing. Okay, so this also works if you're kind of working backwards, when you don't have the angle, but you do have a couple of the sides. The setup is the exact same. The only difference is how we're going to kind of type this into the calculator. Okay, so the acute angle this time is x. We don't know what it is, but we're going to set it up the same way. So we're going to take the tangent of the missing angle, so tangent of x degrees. Don't know what it is, but I do know what the ratio is. So for a tangent of this missing angle, opposite leg of x is the 13 over the adjacent leg, which is 7. Okay, so I've got tangent of x equals 13 over 7. Now before, what we would do is we would put this over 1 and we would cross multiply. We're going to do things a little bit different this time because we're missing the angle. Okay, now if you go to your calculator, you can see my tangent button right above. It's going to be really hard to see from the camera here, but right above that tangent button, you see this little button. It says tangent, and there's a little -1. Okay, this is called the tangent inverse function. Just like with nearly every mathematical operation, you always have what's called an inverse or an opposite. Just like the opposite of multiplying is dividing. Okay, if you go one way, you multiply. To get back to your original value, you divide. Same thing with addition and subtraction, powers and roots, things like that. So a tangent function also has what's called a tangent inverse function. And what we're going to do here is we're going to use that tangent inverse function to kind of zero out or get rid of my tangent function here. So what we do is we take the inverse tangent of both sides of this equation. Okay, so in algebra we got to do it to both sides if we're going to do it to one side to keep everything equal. And what that looks like is we're going to take the tangent inverse of the tangent of x. Okay, and what that does is that gets rid of these two. These two things cancel each other out. So tangent inverse and a tangent, those are kind of gone. I also have to take the tangent inverse of this side as well. So what that's going to look like is I'm going to take the tangent inverse of 13 over 7, that fraction. Okay, so what this does is this is gone, and I'm going to take the tangent inverse of 13 over 7. So that's what I'm going to type into my calculator. So again, depending on your calculator, it might look a little different, but on mine, I hit the second button and then the tangent button, and that pops up the tangent inverse, tangent a little negative 1 there. And then I just type in my fraction, 13 over 7. 13 divided by 7. Okay, and that should give me the measure of this angle x. Okay, and what we get is about 61.7. So 61.7 degrees is the measure of that angle right there. Okay, so don't forget, if you're missing the angle, you're going to have to use the tangent inverse. If you're missing a side, you just use the regular tangent function. All right, so that's the tangent function. Next week, we will explore 2 other basic trigonometric functions, sine and cosine. Okay, so if it's already next week, you're going to find that video right here. You can just go right to it. But as always, leave a thumbs up if this video was helpful for you, and subscribe to the channel to see more videos just like this. Thank you for watching. We will see you next time.